All right, so this is the UPS, the charge box. There's the inverter and the charger that died. This piece of dung right here. So I had an AC that I'd plug into the wall to charge it. And then of course, AC comes out of here and can go to the sump pump or to the fan in the fireplace. So up in here, batteries, makeshift the little latch, keep the thing from falling backwards. It's on wheels, so it's easy to move around. This thing probably weighs right now about, I'm guessing 50 pounds, 45 pounds, something like that. And so one person can carry it, but you want to just be able to wheel it around if you can. Anyway, let me get a close-up of the inverter so you can see what I'm using. So far, I've got two of these, one here, one at the other house, and they seem to be working all right. We'll see. Here's the rear. All right. Okay, here we have the existing circuitry in our house. Obviously, our outlets in the wall are going to the breaker, and then when we installed our walkout, we have a wall that joins the exterior foundation wall, and we ran wires out to an outlet outside, and into that we plug in a sump pump. And the sump pump works great as long as we have power. And that is the crux of the problem. There's only about 3 inches between the floor of the walkout and the door that comes into the basement. We have put in waterproof flooring into the basement, but I would still rather not have water come in. So we need a solution that will allow us to not only survive a power outage and have a sump pump working, but we also want to have a power supply where we can move it around the house and use it for different purposes. For example, in the winter, if we lose power and we can't heat the house, we do have a fireplace with a fan that will heat the house very well. And so we could certainly live in here with just that fan and the fireplace going, and a UPS is what I'm calling it. Okay, so now here's the new design. We are cutting the connection between this outlet and this outlet, and we are running the lines up into another outlet here, a big box. This is a 4-gang metal box that will contain a relay and an inverse plug here, and then we'll still have this outlet functioning as before, but breaker power is going to both this box and this box, and then this box will route power to this outlet to the sump pump. A few months ago, I built this box, which contains 2 lithium-ion 12-volt batteries and an inverter, and the original charger that I had for that died. So I'm taking advantage of this time to replace that charger with a 12-volt power supply and a solar battery controller, charge controller, which I have had luck with before, and not in this particular system, but in a solar system I have somewhere else. And that way we can plug in this power supply into the outlet here, which is normal 110 AC, and then we can run 110 AC from the inverter to this plug, which would provide it to the pump. Or we can just run an extension cord from here to here and power it if this box isn't here. So here we have a pseudo schematic, not a proper schematic, but illustrative, showing normal house AC. So the left side here is basically what I'm calling house AC. The right side is this UPS box from the previous image. Here's the relay. So 110 AC comes in and is constantly charging this solenoid, which pulls down this relay to connect the breaker 110 to go to the pump. So when the house is normally running, this is always charged. If this power is lost, then this spring pulls this up and connects the inverter output to here to the pump. This 12 volts here is simply to maintain charge on the battery while we have power. So here is a better graphic of the two cases of when we have power and when we don't. When we have power, grid charges UPS, charges this relay, which pulls this part of the relay down, which makes the connection to power for the pump. If we lose power, of course, this solenoid goes dead, which releases the relay to flip up, thus connecting the UPS power to flow through to the pump. No charging. This is draining, of course, but that's the point. All right, so this is the moment of truth. I got it all wired up. I have some tidying up to do, of course, but tying down the, let's see, this wire here that goes underneath to charge the batteries. And sorry for my finger, this wire right here is the AC. So we're going to plug it in and see what happens. So you have plugging in, green light on power supply. We are registering 12 volts on the charger. Now I'll try to configure it. Okay, folks, this is just to close up the my video about this UPS. So I had the power supply here that was on the right. Was a metal box with holes in it. That was a 10 amp, 12 volt power supply. But this charge regulator here did not like getting more than 10 amps because it's a 10 amp charge controller. So it was giving me errors, error 8, meaning that the supply was providing too much current. So basically what I put in is this like a laptop 12 volt power supply that's only meant for 5 amps. And this thing is perfectly happy providing a trickle charge to the batteries through the charge controller. So even though the battery was relatively low after my experimentation with the sump pump, which is actually right out here, the sump pump was provided power fine by this battery and inverter combination. But so with this little power supply here, it only charges about 4.4 amps max. So it takes, you know, after I did my experimentation with the sump pump, it took about 12 hours to recharge the batteries. But based on my running of the sump pump, I would guess I could run the sump pump, you know, with a full bore hose going on it. It was doing a pump about every, I don't know, 2 or 3 minutes. And it certainly did 6 or 7 pumps just fine, losing less than a volt out of, say, 12 or 13. So I think it was running fine. I'm going to keep it in this configuration for now. I'm not going to bother to get another pump. You see here, the blue thing is the relay, and this is the plug that will be providing the power into the plug, through the wall, into the sump pump, per my drawings from before. Anyway, that's it for now. Thanks. Bye.